The Zookeeper framework for Mesos team, also known as the Mekeepers. This is our project. My name is Doug, and I was the team leader this semester. And with me today we have Martin, Nick, and Miriam. And we have a mentor, Bill Green, who works for New Relic, who's the client that asked for this project to be done for the open source community. All right, so we're going to do a little bit of a poll here. Who here knows what a computer is? Raise your hand. Oh, that's pretty good. Almost everybody in here knows what a computer is. Who here knows what a data center is? Okay, pretty similar. All right, so for those of you that might not know, a data center is essentially just a bunch of computers that are co-located in the same area that a company uses so that they can have more powerful applications. In traditional data centers, what happens is that all of these computers have to be configured individually, and they run one specific application or multiple applications depending on how they're set up. The problem is this won't necessarily allow you to scale dynamically. If we were to look at this in the eyes of something everybody knows, Netflix, this would be like if every computer had one TV show, right? The computers that have really popular TV shows, like maybe Friends, would get bombarded with requests, and people that are trying to watch that show might not be able to access it because the computers are just overloaded. And computers with unpopular shows wouldn't really be using all the resources. That's where the first part of our project, Mesos, comes in. Mesos is what's called a data center operating system, and it moves from the traditional data center architecture to imagining that all of your computers are networked as one giant computer, allowing you to scale and share resources across computers. This is really useful because now shows that might need more resources can pretty much get it when they want it, and shows that don't need it can give up their resources for other applications.
The other half of our project, Zookeeper, is very similar to Google Maps in that you ask for specific resources and it directs you directly to where you can find those resources within your data center.
So bringing it all together, it's kind of like taking your data center, making it one big computer. And then we wrote the framework that allows for Zookeeper to run inside of Mesos.
Problem that our project is addressing is that Apache Mesos doesn't have a framework for Zookeeper. This means that you have to have dedicated computers if you're running a Mesos cluster just to get the Mesos cluster running and to get the applications that are running on the Mesos cluster Zookeeper functionality. This is like paying for Netflix each month, but also paying for the shows in two separate payments. Our solution to this problem is to take an existing Mesos framework, take apart each of its essential pieces, write a C++ framework of our own, and add the Zookeeper functionality to that.
The results of our fruition is that now we have a Mesos framework written in C++ that includes all of the Zookeeper functionality to run a Zookeeper ensemble within a Mesos quorum in your data center.
Because our project is mainly in the back end, we weren't really able to show a lot of things that are going on. It's really amazing things, but here Mesos has a UI that allows us to show how our project works. So here in the picture, you can see that we have different frameworks running. The frameworks can either be active or completed or failed. So in our picture, you can see that we have different various frameworks completed already. Inside of each framework, we have tasks. And these tasks can be like our shows in Mesos, right? So in our shows are either failed, completed, or not, or lost. This means that we either were able to stream your show, we couldn't find your show, or we just don't have your show at all. So in here, you can see that our project is completely finished. You can see that our tasks are being completed and where we can find where they're located. For our future work, we would like to add some other functionalities, like task reconciliation. This means that if your show got lost or we got killed in this way, we would like to add it back to the queue and start the process all over again and be able to make it to its end. We also would like to add a user interface or an API so that our users can have a better experience when working with our application. And lastly, we would like to submit our project to the open source Apache repository because our solution will benefit a lot of developers who are currently working on the same issue that we worked on. We would like to acknowledge our New Relic mentor, CSUMB staff, and family and friends who helped us with technical and non-technical support. Thank you.